JavaScript language overview. JavaScript is a multi-paradigm dynamic language with types and operators, standard building objects and methods. Its syntax is based on the Java and C languages. Many structures from those languages apply to JavaScript as well. JavaScript supports object-oriented programming with object prototypes and classes. It also supports functional programming since functions are first class that can be easily created via expressions and passed around like any other object. This page serves as a quick overview of various JavaScript language features written for readers with background in other languages such as C or Java. So here you can go to this link, developer.mozilla.org. I'm gonna put this link also down below. So data types. Let's start off by looking at the building blocks of any language. The types. JavaScript programs manipulate values, and those values all belong to a type. JavaScript offers 7 primitive types. So we have the number, the big integer, string, boolean, symbol, undefined, and null. Number. Used for all number values, integer and floating point, except for very big integers. Then we have the big integer, the big int, used for arbitrarily large integers. We have the string, used to store text. We have the boolean, true and false, usually used for conditional logic. We have the symbol, used for creating unique identifiers that won't collide. Undefined, indicating that a variable has not been assigned a value. Null, indicating a deliberate non-value. Everything else is known as an object. Common object types include the function, the array, the date, the regexp or the regular expression. Then we have the error. Functions aren't special data structures in JavaScript. They are just a special type of object that can be called. Now here we have numbers. JavaScript has 2 built-in numeric types, number and big int, the big integer. The number type is a IEEE 754 64-bit double precision floating point value, which means integers can be safely represented between the negative of the subtraction of 2 raised to the power of 53 and 1 and this number, that is 2 raised to the power of 53 minus 1 without loss of precision, and floating point numbers can be stored all the way up to 1.79 multiplied by 10 raised to the power of 308. Within numbers, JavaScript does not distinguish between floating point numbers and integers. So for example, if I go here to another tab, I just duplicate it. If I type in Ctrl+Shift+I in my machine, I'm gonna go to my Windows Chrome DevTools, and from here I can just pretty much copy this one and paste it. So I have console.log. So we have inside the log, I have a division of 3 by 2. So the comment says it's gonna be 1.5, not 1. So I press enter, and yeah, that is 1.5. So you can just type in directly into your DevTools. So an apparent integer is in fact implicitly a float because of IEEE 754 encoding. Sometimes floating point arithmetic can be imprecise. Now we have, for example, another example. I go here, paste it. So I have console.log 0.1 plus 0.2, that would be 0.3. So I press enter, and I have 0.3000 up to 4. So yeah, that is that. For operations that expect integers such as bitwise operations, the number will be converted to a 32-bit integer. Now we have number literals. Number literals can also have prefixes to indicate the base, binary, octal, decimal, or hexadecimal, or an exponent suffix. So here we have these examples here. We can go again, we copy, we paste it. We have the console.log of this number, and then it's gonna be 503, again 503. Then we copy the second one, it's gonna be again, press enter, 503, and you get the idea here. So the big integer, and also you can read more if you click here. You have a bunch of information here. That's the same with the regular expression, the reg xp. So the big int type is an arbitrary length integer. Its behavior is similar to C's integer types, e.g. division truncates to 0, except it can grow indefinitely. Big ints are specified with a number literal and an n suffix. So for example, we have here the console.log in parentheses -3m divided by 2m. So for example, we can grab it and we can go here, paste it, press enter, and we're gonna go -1n. The standard arithmetic operators are supported, including addition, subtraction, remainder arithmetic, etc. Big ints and numbers cannot be mixed in arithmetic operations. The math object provides standard mathematical functions and constants. So here, for example, we have the math that sign of 3.5. Again, we can paste it here, and yeah, you have -0.35, a bunch of numbers. So here there are 3 ways to convert a string to a number. So we have the parse integer, we have the parse float, and we have the number. We can go with the parse integer, which parses the string for an integer. We have the parse float, which parses the string for a floating point number. We have the number function, which parses a string as if it's a number literal and supports many different number representations. You can also use the unary plus, so the plus signal, as a shorthand for number. Number values also include num, short for not a number, and infinite. Many invalid math operations will return none. For example, if attempting to parse a non-numeric string or using math.log on a negative value, division by 0 produces infinity, positive or negative. So here we have none is contagious. If you provide it as an operand to any mathematical operation, the result will also be none. None is the only value in JavaScript that's not equal to itself per IEEE 754 specification.